right, this is from section 5, topic 2. And the topic is writing quadratics from a graph. Oh, what I was writing there. I should say writing a quadratic equation. When given a graph. I'm recording this. Remember, put your name, not my name. And then our essential question, or the target question, is how can we write an equation in standard form of a quadratic when given the graph. And then once you get that down, that whole graph on the front section, we're just putting one graph there. So go ahead and draw yourself an X and a Y axis. And you can make it nice and big because, like I said, we're just putting one there. And when you finish with those rulers today, please make sure that they go back in the supply pouches. Don't just leave them out. That's how they get lost. And last time we used them, they were all over the place at the end of the class. So that stuff is there for you to use, but please, please, please put it back at the end. Because those supplies were not free. I gotta pay for them. So I'm giving you the points to plot on the graph, okay, to make sure all of our graphs are the same. Our vertex is going to be at -1,9. Our y-intercept is at 0,8. Our graph is going to cross the x-axis at 2,0 and at -4,0. Which point are you looking at? Vertex? -1,9.
Okay, thank you.
So last class, they gave us the equation and we had to find all these points. Where's the vertex? Where's the y-intercept? Does it open up or does it open down? What are the x-intercepts? We had to find all of those points and plot them, correct? Well, today we've been given the graph and then we have to write the equation of the graph in standard form. Okay, so it's like doing the opposite of what we did in our last class. So again, I'm going to use the question side of the notes to write the steps down. I don't want to write them on the grid part because those lines are dark and it's hard to see. Okay. So the first thing we're going to do is we are going to identify the y-intercept. And what'd you say it was, Sarah? 8. It's at 0, 8's the ordered pair, but really the 8 is all that we need from it, right? Where does it cross the y-axis? At when y is 8. Everybody cool so far? So far, this is easy. Step 2. Identify 2 other ordered pairs by looking at the graph. And it can be any other 2 ordered pairs. Just don't use the y-intercept. You want it to be 2 different ordered pairs than that. Okay? So I know 3 ordered pairs at this point. I could use -1, 9, -4, 0, 2, 0, any 2 of those points. It doesn't matter. Now, right now, let's all identify the same 2 so that our notes look the same. But when we go to do the work on our own, if you pick 2 different points than I pick, as long as there are 2 actual points on this graph, then our math will be different, but our end result should be the same. Okay? So I'm just going to use these 2 x-intercepts because one of the numbers in the ordered pair is 0, so that's probably going to make some easy math. Okay? So I choose -4, 0 and 2, 0. All right, so now substitute each ordered pair and the y-intercept into the standard form of a quadratic equation. This will create a system of equations. Y'all remember when we learned how to solve systems of equations? Do I need to zoom in on that? Can y'all see that okay? Everybody cool? All right, so I'll start with the first ordered pair. You do both of the ordered pairs separately. Okay, so I'll start with -4, 0. If I wanted to start with 2, 0, I could. It doesn't matter which one you start with. So I'll start with -4, 0. So we know -4 is an x value, 0 is a y value. And it said, now substitute each ordered pair and the y-intercept. So our y-intercept is 8. So that's our c value, right? The y-intercept is the c value. So it says substitute that into the standard form of a quadratic equation, which we know that by heart. Standard form of a quadratic is y equals ax squared plus bx plus c. We've seen that a million times. So in that equation, I have a value for y, I have a value for x that I could plug in, and I have a value for c, right? Only thing I don't have is an a and b. All right, so we'll substitute in what we have. So for y, I'll put in a 0. I don't have an a, so I'll just write a times, instead of x, it's -4 quantity squared, plus bx. So that's plus, I don't have a b, but x, I have -4, And for C, I have a positive 8. And there is another way to do this. I was going to show y'all both ways, 2 different methods. But sometimes I just think that gets confusing. So I chose what I think is the easier of the 2 and went with that. Okay? So let me simplify this. That's 0 equals, what's 4 squared? 16 times A? 16A. Positive B times negative 4 is, what do we say, negative B4? Negative 4B plus 8. And I'm going to go ahead and move that constant over here to the left side with the other constant. So I'll subtract 8 from both sides. 0 minus 8 is negative 8 equals 16A minus 4B. So I have 2 variables in this equation. So it's not like I can solve for A just to get a number or solve for B just to get a number. At this point, I cannot, okay? So I'm going to come back to this equation in a minute. As it said in the directions, we're creating a system of equations. So this is going to be one of the equations in our system. So we use the first point, negative 4 comma 0. Now I'm going to go back and do the same thing with 2 comma 0, okay? And my summary, I'm not using for a summary. So 2 comma 0. So this time I'll use 2 for x, again 0 for y, and C is the same for this whole entire graph. So C is 8. And I'll substitute that in to y equals ax squared plus bx plus c. So for y and this one I'll use 0 equals, I don't have an a, but for x I have 2 quantity squared plus b times 2 plus 8. Simplify that just like we did above. So 0 equals 2 squared is 4. 4 times a is 4a. Positive b times 2, we would write positive 2b. Bring down your plus 8. And just like we did on the other one, I'll move that 8 to the other side. So I have negative 8 equals 4a plus 2b. So I've created a system. I've got 2 equations. They both have the same variables, so I can put them together as a system and solve for A and B. Remember we learned how to do that? You could solve using elimination, you could solve using substitution, or you could solve by graphing, right? So me, I would probably solve by elimination, especially the form that they're in. So I'm going to come up here. Right? These 2 equations that we created as a system of equations then solve for both variables. Messy. Again, I'm going to use elimination. I could use substitution if at least one of those equations had the variables isolated. Even better if they both did. But since they're both written in the same form, our constants line up, our equal signs line up, our a terms line up, our b terms line up. To me, elimination is going to be the easiest, okay? Do my A's eliminate automatically? No. Do my B's eliminate automatically? No. If I want to eliminate my A's, I would multiply the top or the bottom equation in this case? Bottom equation by what? -4, because I need this to turn into a negative 16a to eliminate with a positive 16a, right? I don't want it to be positive 16a, so I'd have to multiply by -4. If I wanted my B's to eliminate, would I multiply the top or the bottom? The bottom by what in this case? 2, and that would turn that into -4b. So I'm probably just going to go with eliminating the B's, which means I multiply the bottom by 2. Okay, so I'm running out of room again. So my top equation, I'm not changing, so I'm just going to rewrite it. And my bottom equation, I'm going to distribute that 2 even across the equal sign. So 2 times -8 is -16. Don't forget your equal sign. 2 times +4a is +8a. And 2 times +2b is +4b. Now the way that I wrote that, are my B's going to eliminate? Yes, which was my goal. So now combine like terms. -8 minus 16 is -24. Bring down your equal sign. Positive 16a and positive 8a. Positive 24a. I just have one variable now, so I can solve for that one variable. Divide each term by 24, and what will a equal? -1. So now I know C is equal to 8. I knew that from the beginning because that's my y-intercept, right? Now I know A is equal to -1. How will I find B? Plug it into where? Either of these two equations. Not the C, but the A or the B, right? Because I know A, and that way I can substitute A equals -1 and solve for B. Does it matter which equation we choose? No, I'm just going to go with this bottom one. Oh, hold on, let me write now, find B. So I'll choose -8 equals 4a plus 2b. I know A is -1. So I'll just simplify that. So my question is, how do we write an equation in standard form given a graph? Have I written the equation? No, I found all of the parts that I need, but I haven't actually written the equation yet. That's the answer. So I have to do that. Of course, I'm out of room. So I'm going to squeeze this in down here. So we know that A is -1. B is -2, and C is +8, right? We know the standard form of an equation is y equals ax squared plus bx plus c. But that's just the generic standard form. That's not the equation of this line. So what do y'all think I do? Yeah. Where I see an A, substitute -1. Where I see a B, substitute -2. Where I see a C, substitute an 8. So that would be y equals -1x squared, which of course we would just write -x squared minus 2x plus 8. Yes, all that work just to get to that answer. So the work's not difficult, it's just a lot of steps, right? Anybody have questions so far? So I'm just going to do one more of these. I'm not going to write everything down, all the words this time. We'll just go back and look at our example 1. Anybody still writing? Okay, if you need to see my notes after this, I'll let you borrow them. Next example. All right, let's draw a big old graph. I know my graph's taking up a lot of space. I'm going to move it up a little bit so I have more room if I need to write over there again. Because I don't want to write in my summary this time, because we'll have to write a summary. So in this one, our vertex is at 1, -2. Our y-intercept is at 2. The ordered pair being 0, 2. Our x-intercept, one of them is at 2, 0. And the other one's not given because it would be an estimate, because it does not fall at an exact lattice, perfect lattice intersection. And we don't want to estimate it, so all we need is the y-intercept and 2 points. And I'm going to write the directions up here in the little notes section, which say, given the graph below, write an equation of the quadratic in standard form. I'm just going to freeze this so y'all can see, and I'll write that out. And once you write that down, look on the other side of your notes and see what did we do first? How did we start this off? We identified the y-intercept, right? Well, that's easy. What is it? 2. So what's that, A, B, or C? C. So we know C equals 2. Can we just look at the equation and figure out what A and B are? No, we wish, but we can't. So according to our notes on the previous page, what do we do next? Yeah, we got to identify 2 other ordered pairs first, right? We don't want to use this one because that's already used once. So we got to identify 2 others. So in this case, I mean, we'll use 2 they gave us. Again, I would want to choose this point right here because it's not at a perfect lattice intersection. That's going to be some decimal I'm going to have to estimate. So even if they did not write these ordered pairs on the graph, choose points that are on a perfect lattice intersection, not in between, okay? So yeah, if this is my y-intercept and I need 2 other points, I'm going to choose these 2. So that is 1 comma negative 2 and 2 comma 0. What do we do with those points?
We sub each pair of an unordered pair.
Bless you. Exactly. We're going to substitute each pair of points and also our y-intercept into a quadratic equation. We're going to make a system, right? So I'll start with 1 comma negative 2. Again, it doesn't matter which one you start with. We know we'll use the 1 for our x value, the negative 2 for our y value. Could I do the inverse of that? Could I use 1 for y and negative 2 for x? No, it's an ordered pair. The first number is x, second number is y. And then we also use the value of c. Right? You don't want to forget that part. You're not going to get the right equation if you don't put the right value for c in. So write my equation in standard form, so I have it right there in front of me, and then I'll substitute in a 1 for x, a 2 for negative y, a negative 2 for y, and a 2 for c, and that leaves me with a and b that I don't know. When I do it in the other equation, I'm going to have a and b that I don't know. I'll create a system to find a and b. So 2 equals a times 1 quantity squared plus b times 1 plus 2. So, oh, I knew I did something wrong. My y should be negative 2. Thank you. Not positive 2. So let me simplify that. I get negative 2 equals, what's 1 squared times a? A. What's positive b times 1? Positive b. And then I bring down the plus 2. I'm going to move it over to that constant on the other side because they're like terms. So I have negative 4 equals a plus b. What do I do with that at this moment? Exactly. We wait until we find the other equation using the other point that we chose, right? So the other point we chose was 2 comma 0. The x's are 2, the y is our 0, and then we still use our y-intercept for c, which is 2. And I'm going to do the same thing I did above. Except for this time, for y, I'll substitute in a 0. And for x, I'll substitute in a 2. And c is the same, still 2. So that gives me 0 equals 2 squared times a is what? What? Close. Do 2 squared first. 4a. Plus 2b. To be or not to be? That is the question. And then I'll move that constant over. So that's negative 2 equals 4a plus 2b. So I created another equation. Now what? How am I going to solve for both? What do I do to solve? Right, so I'll put them in a system, and then use elimination. I could also use substitution or graphing, but I would suggest elimination. So I'll bring these two equations. Negative 4 equals a plus b, and negative 2 equals 4a plus 2b. And I'll solve a and b. Do either of my variables eliminate automatically? No. What do y'all think is going to be the easiest one to eliminate? What? The B's. And really, it's not any easier than A's. I'm still multiplying by a positive number, but it's just a smaller number, right? So that's what I would do. You could do the A's, it's fine. If I want to eliminate the B's, I will multiply the top or bottom equation, top by negative 2. So that gives me positive 8 equals negative 2a minus 2b. The bottom equation, I don't have to multiply that by anything. So I'm just going to bring that over and line everything up. And I get 8 minus 2 is positive 6. Bring down my equal sign. Negative 2a plus 4a is positive 2a. And my b's canceled. Solve for a, divide everything by 2. So a equals 3. So I need to know a, b, and c. I know a, I know c. I can't write the equation until I know b. How am I going to find it?
You put in the A. You plug it in.
Substitute a into what?
Any of the ones you want. The top one. Because it's just A.
Okay, so we're not talking about like the original. Well, we don't even have original equation. So yeah, either one of these that we created, right? All right, so you want to go at the top? That's fine. So that's negative 4 equals a plus b. I now know that a is 3. So instead of a, I'll substitute in a 3. So now I just have one little old variable. When I solve for it, what do I get? Negative 7. So now I know that a is 3, b is negative 7, and we've always known that c is 2. Is that my answer? No, it said, given the graph below, write an equation of the quadratic in standard form. We have not written an equation. So we know the standard form of a quadratic equation is y equals ax squared plus bx plus c. So we write y equals what? 3x squared minus 7x plus 2. And that's our answer. Wasn't too bad, was it? Oh. Easy math, just a lot of steps. So now I'm going to give you 4 problems. The first 2 are just like what we did yesterday, what your homework was on, where I give you the equation, you have to come up with the graph. Okay, you've got to show me all the work. How did you find each step? The second 2 are like what we did here. I gave you the graph. I'm actually not even giving you the graph. I'm giving you the ordered pairs. You can plot your own graph, and then you have to write the equation. You must show me all steps. You just throw a graph on a piece of paper, that's not going to get you credit. You got to show me your work. Okay? So I took your notes from yesterday. I'm going to put those in my grade book real quick, and then I'll give them back to you. So what I would do when I put the homework up, I would do the second 2 first, because that's the notes that you have in front of you. And then when I give you those other notes back, then I would go back and do 1 and 2. Okay? Unless you can remember how to do 1 and 2 without the notes, then sweet. But if you need that for backup, then do those when I'm passing back. You may have any questions?
Yeah, graph paper.
I have graph paper, yes. Let me get this video stopped, and then I'll take care of all that.
Where does it say negative 3 equals negative 3?
Negative 3 equals negative 3?
Where you said b equals negative 7. Go left.
Subtracting the 3 on both sides.
Oh, down here?
Yeah.
So I was solving for b, right? So I needed to move this 3 over. So I subtracted 3 from both sides so that that would make my 3's cancel. so I could solve for B. Is that what you're asking?
Yeah.
Okay.